What is up, everybody, all the viewers? John here, Thermal Solutions Heating and Cooling. Today we have a compressor replacement on a rooftop unit. The compressor went bad, and here we have the replacement. It's a Copeland scroll compressor, and we have a toolable boom lift just to make everything efficient as possible. One trip up, we have all the tools we need up there, and one trip down, we have all the tools down here to load up on the van when we leave. Efficiency. So let's get straight to the video, and I'll show you quickly here the tools I have: umbrella, vacuum pump, some waters, compressor parts. I have a contactor, a liquid line filter, my True Blue evacuation hoses, recovery machine, recovery cylinder, nitrogen, so when I braze, I purge with nitrogen, tool bag, extension hoses or extension cables, manifold here, analog manifold. Somewhere here I have my other manifold. Somewhere my probes and rags. That's what I have up here. But let's get straight to it now. Alright, this is where I'm at. I got all my tools all scattered around. I try to get a canopy up here to get some shade. Extremely hot, but it's way too windy and it keeps knocking down my tarp there, so no shade it is. I'm going to start doing the recovery on compressor number 1. It's off, so I'm going to go ahead and start the recovery process. I have my recovery machine right here. I got my manifold out there, recovery cylinder. I'm going to get straight to that. Okay, so now I just finished pulling all the refrigerant out of the system, and yes, I pulled a vacuum on my recovery tank. I have my True Blue 3/4 inner diameter hoses. I pulled vacuum on my cylinder, 250 microns, and then I was ready for the next step, which is adding refrigerant into my tank. And if you're asking why I'm using a 15-gallon tank, that's because that cylinder has 6 pounds of refrigerant, so I couldn't use that one, so I had to use my backup, which kind of sucks because that one I have my bucket just for this purpose, because that cylinder gets hot, so I can just put my recovery tank into my bucket with cold water and ice. But I had to work with what I had, so I have empty buckets of water, and I was just pouring cold water into it. But it got done. Right now I'm at 0 pressure. So now I'm ready for the next step, which is take off that compressor, take off the filter dryer, and get the new components into the system here. long enough. Part of the system. So now, new compressor in, both refrigerant lines are going into the compressor, and everything is prepped up. I have nitrogen going into my suction line and is exiting out the high side where my straighter valve is removed right here. And refrigerant lines are, I took a long time to get those really clean, so when I braze, I have an easy time brazing. So that's the setup so far. Now time to get those brazed in. Oh, and if you see that this rag here, that's, I have the suction line pulled into that compressor because it kept popping out on me, and I'm alone, so this is I used the t-shirt, I tied it together just to hold that suction line in there. So let's get it done. Ended up taking this panel section off for me to have access to my liquid line filter dryers. I originally was going to do it up here, but then I realized it would have been very uncomfortable and awkward if I could actually even get to my liquid line filter dryer to braze in the new one. So I looked for a different approach, and I saw this was an option, so I immediately took this panel off. So these are my liquid line filter dryers that I have to replace. And I'm only going to replace for circuit number 1, which should be this one here for circuit 1, compressor 1. So take this off and get the new one in. So here's a little funny incident that just happened, and I'm showing my mistakes as well. This is a real world. Everything ain't perfect, and there's gonna be mistakes, and I'm probably gonna keep on making them too. And of that I'm certain. Anyhow, use my mistakes as to your benefit, so that way you don't make the same mistakes I'm making now. Anyhow, I was getting ready to remove that liquid line filter, and I was pretty sure I followed the lines, and I was pretty certain, but I didn't double check, which was my mistake. I didn't double check if that was for circuit 1 or 2. I was confident that it was circuit 1, but again, I didn't double check. And this so happened to be for circuit number 2. Because that filter goes for on this side of the evaporator, and that compressor goes on this side here. So the liquid line filter that I need to be replacing was that the further one down, the one on the inside. That is the liquid line filter that I was supposed to be removing. So like I said, my mistake here wasn't double checking. I felt confident, but confidence shouldn't exclude double checking. So what happened after I heard that hissing sound, which I knew immediately it was refrigerant coming out, I started recovering the refrigerant on the second compressor, and I'm already at 0 pressure, so it's already inside that tank there. So now I can go ahead and proceed with removing. Well, now I'm actually gonna end up taking both liquid filter dryers off and replacing both of them. But this is what it is. Sometimes we make mistakes, and I'm not afraid to show it. So let's go. Let's do this. Now it's good to have OEM replacements, but I only ordered one filter dryer since I originally was only going to replace one. But I have this Parker filter dryer, which is rated for the same capacity. This is a 083 S, and so is this one, 083S. Right here, if you can see that. And then back here, you have all the information you need. 083S. You transform it, you go to air conditioning, and you see what it's rated for. So this filter dryer is, I'm using it in replacement of OEM since I didn't have one on hand. This is what I had on hand. It's rated for the same capacity. 083S. 083S. And down on that end, it's not on camera, but down here, I have nitrogen purging about 5 psi, and it's running through the system. That way, it doesn't build up any that carbon from the brazing. Alright, so now this is where I'm currently at. I have both refrigerant lines on the compressor brazed in, liquid line filter dryers are also done. Right now I'm just purging the system just to make sure I get all that junk out of there. I have it set to 30 psi. You can go anywhere from 20 to 50 psi going through the suction line. I close off my valve, my core removal valve. I let the pressure build up and I release. And I let my pressure get to 0. And then I close it off again and I let that pressure build. I do that good 2-3 times. And then once I get that done, then I'll pressurize the system, make sure I have no leaks, double check. We want to double check just to avoid any extra labor. Pressurize the system, double check to make sure there's no leak, and then if there's no leaks, then next thing we do is I start setting up all my tools for evacuation, and then pull vacuum on the unit here. Right now I'm double checking all these joints that are here. Might as well. That joint there. No bubbles. So we are good here. Now here's a compressor. There. We are good. No bubbles. Alrighty, so now I'm pulling a vacuum on my system. I have both Schrader valves removed, and I'm using my 3/4 inner diameter hoses, like so. And I got a micron gauge right there reading. Right now I'm about 2 minutes in, and I'm already at 700 microns. So she's pulling deep and mighty. Make sure, yep. So meanwhile that pulls, I'm gonna start putting my my enclosed frame to close this off, get this condenser fan motor tightened up, and start getting everything squared away. I got new fresh vacuum pump oil in there, and since I'm at 700 microns, 500 now, I can close off the gas ballast valve on my field piece vacuum pump. This is a 10 CFM. That's the vacuum pump I'm using. 10 CFM. And the hoses that I'm using, 3/4 inner diameter And this is a the brand vacuum pump or hoses I'm using. True Blue evacuation kit. All that comes in a kit. It comes with vacuum rated core removal tools. Pays to have good money or good tools. Pays good to have good tools. And if you're in this trade, invest in good tools. You won't regret it. And you can already see I pulled a deep vacuum under 10 minutes. Alright, so we've been about 10 minutes now. It looks like the micron gauge it held. We're under 300 microns right now. So we are ready for the next step. I have that closed up. Got my I still have my condenser fan that I needed to do, so I'll do that, and then I have to replace also. It's good practice to also change a contactor when you're replacing a compressor, so I have a new contactor right there. So next I'll be changing that condenser fan, or adding that condenser fan motor, and then replacing contactor number 2, or contactor number 1, which I already wrote last time I was here to diagnose. On the last service call, I was here to diagnose that compressor. I wrote it down, so this is the one I have to replace that. It's always good practice to do that, and let's get on it then. So like I said, it's always good practice to replace that contactor, and I have an OEM contactor here, which is a direct like for like replacement. And it's always good to write down the colors on this. So yellow, blue, black, because it's important that you do that you note that down, because these compressors are phase sensitive, so you have to make sure the rotation of the voltage is correct. And if you put your electrical wiring wrong, then you'll have reverse rotation, which will cause compressor to overheat. But even though we're writing this down, we'll double check that when we have power up, because even though it's like that, it doesn't mean it's right. You should still need to do your job and make sure that everything's correct. Up here we have orange. This is tan, orange, and purple. New contactor is in, and thank goodness for that I was recording, because when I was getting my hands in here, I yanked this off and I didn't know where it went. I referred to the video and it went here. Anyhow, contactors in. Now if you don't have these contactors, they have a rating for your torque, which is, you see there, 22 pounds of torque on your nugs. You guys see that? Now, if you don't have a torquing screwdriver, then you can use your hex keys, one of these, and just get it nice and tight where these aren't loose. And you can verify that. You can pull on these wirings here, and they're not loose. Nothing's moving around. Because if they're loose, then you can actually cause this contactor to go bad. So make sure they are tight. See, and I'm yanking on these. You can see my hand there. I'm yanking on them, and they're not budging. They are tight. These are all tight as well. And also, if you want to double check your wiring, these wires, they have a number on them. See that 107? You see 107, and this one has. They all need to have numbers. Sometimes it's on the other side, but for example, this one 137. This is 139. This one probably is 138. This 10 wire here, 138, 139. And 107, and this one is 108, 107, 108, and it's more likely 109 right here. It's probably there somewhere. But then you could refer to the wiring diagram, and then you can double check all your wiring. You go to your wiring diagram, and you make sure 108, 107, and etc. They go to its designated area, because remember, these are phase sensitive. They need to have the correct rotation. So just a food for thought, and for you to something for you to consider. To introduce refrigerant into the system, I've already done all my math. So this compressor takes, this one takes 8.8 pounds, 2 ounces, and you can always refer to your naming plate. I've done the math here. Compressor 1 is 8 pounds, 2 ounces. Compressor 2 is 7 pounds, 14 ounces. Just roughly right under 8, because there's 16 ounces in a pound, so 2 ounces off. My refrigerant jug starting weight is 32.6 pounds. So I have that on my scale. So 32.6 minus 8 pounds, 2 ounces. That's what I should do the difference. That's what I should have into this compressor. Alright, so I've already added refrigerant into the system. I added liquid refrigerant through the high side, as you can see right there. And I've done all the math already. I already explained that to you guys, the math there. So this way, if we add liquid refrigerant through the high side, this is actually the safest way for the compressor. And this is because that liquid refrigerant will travel and flow to your metering device, which we have a thermal expansion valve, and then it will phase change, and then it will run through your refrigerant lines and go to your compressor almost as a vapor, as if the compressor was running. And then once it reaches its limit, because not all 8 pounds of refrigerant is gonna, you're not gonna be able to introduce all 8 pounds of liquid refrigerant. For example, for us, in our instance, we stopped at just about 5 pounds, so we need 3 pounds left that's required of this compressor. So then what we will do next, we will turn on the compressor and add the remaining 3 pounds with the system on through your low side. And then we will also do that to your second compressor. Like and repeat. We have 3 hours of sun and a half. I gotta get this done today. I've explained the how to add refrigerant through with the system off. Explain what needed to be explained. So let's hammer away. So right now, compressor number 1 kicked on. So I moved all my probes. My temperature clamps for cycle or for circuit 1. Temp clamp there. Probes, purged my lines, make sure there's no air in there. And I also changed my temperature clamp for circuit number 1 after the filter dryer. And those are my pressures for compressor number 1. Still low. I need to slowly introduce about 3 pounds in there. Woo! Got late on me, son. Moon went up, sun went down. System's all done. I'm just doing the last final touches. And let me show you the pressures. These are it. 15 superheat, 7.5 subcooling. It looks good. And I'll show you my Delta T as well. Down here I'm checking for Delta temperature difference. If you guys can see, I have 51.5 on my supply side, and on my return side I should have around 70 some. So I'm letting that catch up. 61. It's going up. However, it'll be around 70 degrees. So that's a good temperature difference. Seeing it's rising, that pressure, that temperature. $66 degrees. And it's slowly going up. I have probably even more than 20 degrees of temperature difference. But this is a wrap. I like what I see. Everything looks good. Whew. It's a lot of work for one guy, but I can't complain. Well, thank you everybody for watching. Hope you guys learned a thing or two, either from my mistakes or from what I have to offer to teach. Either or. Use it as your benefit. And off to the next video, hopefully soon, and time to get off and take these tools down and go home, rest, and have a beer. It's 5 o'clock somewhere, huh? That's what they say. And on a side note, so these are where you check Delta T. This is your return, and this is your supply. You know when these systems being commissioned because, or due to the fact that there's an insulation in there. If you can see, when they are commissioned and when they are tested, you have to puncture a hole in there. So when I took, there's a rubber or a plastic grommet that goes in there. I took it off and I seen it was never punctured. So it was never, those Delta T's, they were never checked on startup. Just a little side note. Thought I'd share.